Hello, my little scientist. I am Srishti ma'am, your science teacher is back again. Before we begin, tell me, how is your mind today, students? And are you all feeling healthy and energetic? Because today we are going to use both our brain power and body power to explore the amazing world of force, work, and energy. Have you ever wondered how a tiny screwdriver can fix a big cupboard? Or how the sun sitting so far away gives us light, heat, and even electricity? Today we are going to unlock the secret powers of force, work, and energy. Today we are going to learn something very interesting. Tell me, have you ever pushed a door to open it? Or pulled your school bag? And boys, definitely you all have done this. Kicked a football. Or everyone switched on a fan? I guess the answers are all yes. Yes, students, you were using force and energy. Now, don't worry, let us understand these concepts step by step in a very simple way. What is force? Force is simply a push or a pull. When you push or pull something and it changes its position from one place to another, you are applying force. Example, imagine a cricket match. The bowler throws the ball. He uses force. The batsman hits the ball out of the boundary. He uses force. And obviously, the fielder stops the ball. How's that? Yeah. Students, again, he is using force. So, force can, number one, move a body. Number two, stop a body or stop a moving body. And number three, change the direction of a moving body. As per the image you all are seeing on your screens, the kids, like all of you all watching, are playing the game of tug of war. They are using force to pull the rope towards them. Now, let me ask you all one simple question. Leave down the answers before I ask the question. Leave down all your answers in the comment section below. So, the question is, if a football is lying on the ground and no one touches it, will it move? Or will it not move? You're having 10 seconds to answer. Tick tick 1, tick tick 2, tick tick 3, tick tick 4, tick tick 5, tick tick 6, tick tick 7, tick tick 8, tick tick 9, tick tick 9.5. Sorry. Finally, tick tick 10. So, what is the answer? Unfortunately, it will not move because no force is being applied. Right? Okay. Now, let us see some examples from our daily lives. You can see this girl is exerting force on the door to change its position. So, as we discussed, force is the push or pull that causes an object to move from one position to another position. Moving on to the next topic, We will understand the various types of forces. Students, we are having two types of forces. As you can see, contact forces and non-contact forces. Contact forces need touching, while non-contact forces can act from a distance. Both these types of forces helps us to understand how objects move, stop and interact in our daily lives. Let us start with the contact forces. These forces act only when two objects are touching each other. Number 1, friction. Friction opposes motion when two surfaces rub against each other. Like for example, when you slide down a slide in a park or in your playground, you slowly stop at the bottom, right? Why don't you keep sliding forever? Yeah, because of friction. Friction is the force that slows down or stops moving objects. Without friction, we would slip while walking and vehicles would not stop forever. One more example of frictional force is when you slide a book on a table. It slowly stops because of friction, right? Okay. Number 2, tension is the pulling force through a rope, string, or a cable. For example, when you pull a bucket from a well using a rope, tension acts in the rope. Number 3, normal force. This is the support force given by a surface to an object resting on it. For example, a table pushes upward to support a book placed on it. Moving on to the fourth type, air resistance. This is a type of friction caused by air that slows down moving objects. So students, this is also one application or this is also another type of frictional force only. For example, a parachute slows down a skydiver because of what? Because of air resistance. Moving on to the fifth type of force, applied force or we can say muscular force. This is the force applied by our muscles. For example, lifting your school bag every day when you're coming to school in the morning, pushing a table or cycling. Whenever we use our body strength, we use muscular force. For example, when you are clapping your hands, which force are you using? Yeah, you are using your muscular force. Or pushing a door open or kicking a football. Yeah, students, everything, these examples are of muscular force. And finally, the sixth type of contact forces include the force exerted by a stretched or compressed spring is referred to a spring force. For example, a stretched rubber band snapping back to its original shape. Now there is another name for this spring force. Can you tell me? Yeah, it is elastic force. Correct. Elastic force is also used or can also be seen in various other places like a catapult, bow and arrow, etc. Now, before moving on to the various types of non contact forces, I want to ask one small question again to my little scientist. Can you tell me the answer? Yes. So the question goes, is friction always bad? Or is it sometimes helpful? Think, and leave down your answers in the comment section. I will be seeing and telling the answers in the comment section only. So, let us move on to the next type of forces, non contact forces. These forces act without physical contact, without any touch. It doesn't require any kind of touching or touch like the contact forces. Number one, gravitational force. The force by which the earth pulls objects towards itself. Have you noticed that when you drop a pencil, it falls down? Why doesn't it go up? Because the earth pulls everything towards itself. This pulling force of the earth is called gravitational force. If you throw a ball upwards, why does it always come down? Or an apple falling from a tree, why is it always falling down? Yes, students, it is only and only because of gravitational force or gravity. Number two, magnetic force. The force through which magnets attract or repel objects is known as magnetic force. A magnet attracts iron nails. It is having two poles as you can see on your screens, North Pole and South Pole. If there are two magnets and both of the magnets are facing North Pole, will it attract itself or will it repel? Tell me. Yes. If one magnet is having North Pole on its one end and another magnet is also having North Pole on its one end, if we push the magnets towards each other, they will repel each other because same poles or same sides of the magnets repel each other. But if you just rotate it to the other side of the magnet, you will be having the South Pole. Now, when the North Pole is on one side of a magnet and the other magnet is having a South Pole on its side, it will attract each other. Okay, students, you can try this at your home. You can buy two magnets and you can try this at your home and see with your own eyes. Moving on to the third type of non-contact forces, electrostatic force. The force between electrically charged objects. Example, a rubber balloon sticking to a wall. Okay. Now, let us move on to the next part of the chapter. Work. What is work? In our daily life, we say, I worked very hard carrying my bag. But in science, work has a special meaning. Work is done when force is applied and the object moves through a distance or over a distance. If there is no movement, there is no work in science. For example, if you stand like this boy holding a heavy bag for 5 minutes, are you doing work according to science? No, students, because the bag is not moving. But if you lift the bag from the ground to the table, now you see some work has been done. Because work done means force multiplied by distance. On your screen, you can see the formula is given for work done. Work done uses the formula W equals to F multiplied by D. Here, F means the force used and D means the distance the object travels. For example, lifting a bag involves applying force to move it upwards. Understood? I think it's quite easy to understand by seeing these images showing in your screen, showing on your screen, students. Now, let me ask you one simple question. Can you answer? If you push a wall and it does not move, is work done? Why or why not? Tell me the answer in the comment section. Okay? Now, you can very well understand by this simple representation on your screen. See, the boy is pushing. That means force multiplied by the distance moved by any object is referred to as work done. Now, moving on to the next part of the chapter. Simple machines. Simple machines. What are simple machines? Simple machines are tools that help us perform tasks with less effort. They include levers, pulleys, inclined planes, and more and more and more to make our everyday activities easier and more fun to accomplish. Now, children, imagine this situation. You have to lift a very heavy box. You try lifting it directly. It feels difficult, right? But then suddenly someone gives you a long stick and asks you to push from one side, and suddenly it becomes easier. Why? Because you used a simple machine. Simple machines are tools that, number 1, makes work easier. Number 2, reduces effort. Number 3, helps to lift heavy loads. Number 4, change the direction of force. And number 5, sometimes it also helps us to do the work faster. They do not reduce the work completely, they can only make it easier. See, students, I have shown various examples of the simple machines we can see in our daily lives. Number 1 is lever. A lever has a rigid bar and a fixed point called fulcrum. Very simple example, we can see a boy is sitting on a seesaw. When one child goes down, the other one goes up. Why can a small child lift a heavier child? Because the fulcrum helps in balancing the weight. Some other examples of levers are scissors, bottle openers, nutcracker, crowbar, etc. Question time. If you move the fulcrum closer to the load, will it become easier or harder to lift? Why or why not? Think and let me know the answers in the comment section. Moving on to the next type of simple machine, wheel and axle. This machine has a big wheel and a small rod called the axle. When the wheel moves, the axle moves too. It helps in smooth movement and reduces friction. We can see a wheel and an axle in a steering wheel of a car, bicycle paddle, and in screwdriver as well. Without wheels, vehicles cannot move and life would be very difficult, right? Moving on to the third type of simple machine, a pulley. A pulley is made up of two things, a wheel and a rope passing over it. It changes the direction of force. For example, when villagers pull the rope downward, the bucket moves upward and it is easier to what? It is easier to draw some water from a well because we can use our body weight and it is easier to pull down than to lift up. Can you think and tell me the answer of our question related to pulley? Why are pulleys used in big construction buildings? Can anyone answer? Think and answer me in the comment section. Right. Moving on to the next type of simple machine. Inclined plane. An inclined plane is a sloping surface. Instead of lifting something straight up, we push it up slowly on a slope. For example, a ramp, a slide, moving heavy boxes into trucks. It reduces effort but increases distance, right? Now moving on to the next type of simple machine, a wedge. A wedge is made of two inclined planes joined together. It is used for cutting, splitting, piercing, etc. We can see a wedge in various examples in our daily lives, like in a needle, in a knife, etc. Sharper the wedge, less force is needed. And finally, the last example we will be discussing today in our class of simple machines is the screw. A screw is actually an inclined plane wrapped around a nail. Its grooves help to go inside wood easily. Hold things very tightly. The more grooves, the more turns, the more tighter will be the grip of a screw compared to a nail. Now, can you tell me why do screws have these grooves and why do the nails do not have any kind of grooves in it? Which one will you use to put or hang your favorite picture or favorite image on the wall of your room? Tell me. Think about it and let me know in the comment section. Finally, moving on to the various types and forms of energy. The types of energy, there are various types and forms of energy. Let us move to something even more powerful, energy. What is energy? Energy is the ability to do work. Without energy, I myself will not be able to speak right now. You cannot run. You cannot even think properly. Energy comes in many forms, including kinetic, potential, heat, light, sound, and electrical energy. Each type plays a crucial role in our everyday lives, powering everything from toys to lights. There are various types of energy in our daily life. See, I have represented some of them on the screen itself, like solar energy, the energy coming from the sun, the biggest energy source available. Plants trap this sunlight and make food. That means we get energy from the sun indirectly through food. There are various uses of solar energy, like in solar cookers, solar panels, solar heaters, etc. Next, we know that there is another form of energy just like the solar energy, that is wind energy. Moving air has its own energy, which makes the windmills rotate and produce some electricity for us. Correct? That type of energy is referred to as wind energy. It is clean, renewable, and pollution free. The next type of energy we will be discussing is water energy or hydro energy. Flowing water has its energy in itself. Big dams store water. When water falls, it rotates the turbines, and the turbines generate electricity. This is the reason why dams are built near rivers to produce hydroelectricity. Right, students? Moving on to the next type of energy, geothermal energy. Geo means what? Earth. And energy coming from inside the hot earth is referred to as geothermal energy. This energy in some countries is used to produce electricity and heat buildings. The next type of energy is atomic energy. Energy coming from splitting of atoms, which produces a huge amount of energy, is called atomic energy. It is also used to generate electricity and is also used by various countries as a defense in the defense areas to build atom bombs as well, atomic bombs, hydrogen bombs as well. Okay, so it is a type of energy which needs to be used very wisely and very safely. Now, energy changes and conservation. Energy transforms from one form to another every day. For instance, electrical energy powers our bulb, converting it into light, showcasing the importance of conserving energy in our daily lives. Energy can change from one form to another, like heat energy, burning fuel, ironing clothes; light energy, sunlight, bulb; sound energy, clapping, loudspeakers, etc. When we eat, the chemical energy is getting converted into muscular energy, right? How? How is it happening? Because chemical energy is stored in the food molecules. Now, when we are chewing the food, we are using our muscles, we are using our jaw muscles present in our face, present in our mouth, right? So, that is why the energy is changing from chemical energy to muscular energy. When you switch on a fan, which energy changes into which energy? Yes, electrical energy is getting converted into mechanical energy. There are various other examples, right? Like for example, beating of a drum. We can see that muscular energy is getting converted into sound energy. Burning of a candle, chemical energy getting converted into heat and light energy. Electric motor, electrical energy getting converted to mechanical energy, right? There are various other examples which you can see in our daily lives. See students, I have also mentioned some other energy transformation in our daily life. Some examples: a lamp turning electrical energy into light, a blender, mixer grinder turning electrical energy into motion, a bicycle turning your paddling into movement, a solar panel turning sunlight into electrical energy. Now, finally, we are towards the end of the chapter and we need to discuss about some ways to conserve energy. Conserving energy is important for our planet. Simple actions like turning off lights, using less water, and saving fuel can make a big difference. Let's all be energy smart. Okay? Okay. Before going to the quiz portion, let us look down on the various parts, or just let us look or let us understand a small summary of all the points or of all the topics we have read in this entire chapter. Okay, so my dear students, today we have learned that force is a push or a pull. Work is done when force moves an object. Simple machines make work easier. Energy is the ability to do work. Energy can change from one form to another, right? Next time you climb stairs, open a bottle, or switch on a fan, remember you are using science. Okay? Which force now let us move on to the quick quiz which I have set for you all. Tell me what will be the answer. Which force helps us to stay on the ground? Gravity, magnetism, friction, or air? You are having 10 seconds to answer. Time up, time up, time up, time up. Leave down the answers in the comment section. Thank you, students. Keep observing, keep thinking, and keep learning, because every small action around you is full of science. Bye bye. Thank you.